We left off here in the last video. We said that if both sides cannot be written with the same base, then we need to follow down a different path in our flow chart here. Okay, could both sides be written with the same base? What if the answer is no? Okay, so before we actually figure out how it is that we're going to solve equations like this, we need to review our knowledge of logarithms. Okay, so every mathematical function has got to have an inverse. Okay, we need something that's going to undo an exponential or solve an exponential. So we need an inverse for exponentials. Okay, and logarithms are in fact the inverse of exponential. Okay, all right, so our rule is if b to the n power equals some output called x, then that same fact can be written as log base b of the output equals the exponent n. Okay, so basically what we're saying is if we write this in the form of a logarithm, we're saying b, if the base is b and we get an output of x, then what power would there had to have been? This answers the question, what power? So log base b of x means what power of b gives the output x. Okay, so the answer to a logarithm is a power. It is the inverse of exponential. All right, so we're going to do a few examples here. We're just going to go back and forth. I'm going to give you a fact written in exponential form. Okay, and you're going to just rename that same fact in logarithm form. Okay, so I'm going to start out each time by writing the letters log. Okay, the base of a logarithm, it will be the same thing as the base of the exponential. So we'll have log base 15 of 225 equals the power 2. Okay, so basically even though we read it as log base 15 of 225, what we're literally thinking is what power would I put on 15 to give the output 225, and the answer is the exponent 2. All right, number 11, log base 7 of 343 equals the power 3. Okay, number 12, and again, these are all facts. 7 to the third is in fact 343. 11 to the negative 2 is in fact 1 over 121. Okay, so log base 11. Now when the part inside the logarithm is anything more complicated than just a single number, I tend to put that in parentheses. You don't have to, but especially if there's an operation, that's usually what we do. So log base 11 of 1 over 121 equals the power negative 2. Okay, all right, here's more facts. 49 to the 1/2 equals 7. We remember that a 1/2 power is the same thing as a square root, so this is a fact. 49 to the 1/2 means the square root of 49, and that does equal 7. So in logarithm form, that would be log base 49 of 7 equals that power of 1/2. Number 14, 8 to the 5/3 equals 32. Log base 8 of 32 equals the power 5/3. All right, and then here's a fact that includes some variables. We don't even know what a and b are, but we can write that in logarithm form. Log base a of b equals the power 3. All right, in the next section, we're going to go the other way. Okay, if log base 6 of 216 equals 3, that can be written as 6 to the 3rd power equals 216. Okay, number 17, log base 10 of 1 million equals 6, so 10 to the 6th equals 1 million. All right, number 18, log base 144 of 12 equals 1/2, so 144 to the 1/2 power equals 12. Number 19, log base 4 of 1 over 64 equals negative 3. Stated as an exponential would be 4 to the negative 3 equals 1 over 64. Number 20, 4 to the 5/2 equals 32. And then 21, 3 to the 7th equals y plus 2. Okay, so now we're going to take our knowledge of logarithms and we're going to use them to actually evaluate. I'm not going to tell you what log base 6 of 36 is. You're going to have to think through what power would I put on 6 to get 36. And the key here is remembering that the answer to a logarithm is a power, an exponent. So we read this as log base 6 of 36, but what we are thinking to ourselves is what power would I put on 6 to get 36, so the answer is the power 2. Log base 3 of 27, what power would I put on 3 to get 27? So the answer is 3. Number 24, log base 5 of 1 over 5, what power would I put on 5 to get its reciprocal? 1 over 5 would be negative 1. Now, this is an interesting one. What power could I put on 4 to get negative 16? I'm never going to be able to raise a positive base, and all of these will always have positive bases. Okay, I'm never going to be able to raise a positive base like 4 to any power and get negative 16. So that's a good thing to know if you can wrap your brain around that, that if you have a negative in a logarithm, it's going to be undefined or no solution. Okay, 26, what power can I put on 8 to get 1? 8 to what power equals 1? That would be the 0 power. And then this one's interesting, log base 8 of 16. Most people, not most people, but some people are not going to be able to look at that and figure that out. Okay, it's not 2, by the way. Don't divide 16 by 8. Here's a strategy you can use if there's any of these that you cannot solve in your head. Say log base 8 of 16 equals some power that I don't know. Okay, so if we take this and rewrite it in exponential form, it would be 8 to the x equals 16. Now all of a sudden I have an exponential equation, but if you remember back to the last video, I have something where both of these can be written with the same base. 8 is 2 to the 3rd to the x, and 16 is 2 to the 4th. So now I can drop those bases out and say 3x equals 4, so x equals 4/3. So now I know that my answer up here for x is 4/3. All right, before we move on to the next section, we're going to talk about two special logarithms, okay? A common logarithm is a logarithm with a base of 10, okay? And because it is the one that we can leave out, okay, it is because it's the most common, because our entire number system is a base 10 number system, then we can actually leave out the base 10. If you see an log without a base written, it's understood to be a base of 10. And then I'm going to introduce you also to a natural logarithm, although we're going to have to come back to this a lot more later. This is a logarithm with a base that is a special number called e. Okay, it's a natural logarithm, which we write ln for logarithm natural of x. Okay, so we'll come back to that a little bit more. I want to go ahead and introduce you to that before we move on. Okay, now we've got a couple of examples here. I want to look at a couple of these real quick, and then we'll move on in just a minute to another video. Okay, but I'm just going to do 28 right now. 10 to the x equals 20. Okay, we said that in our last strategy was rename both sides with the same base. Well, there is no base that both 10 and 20 can be written with. Okay, so our strategy is going to be, well, if it's not working for me in exponential form, let me do the inverse. Let me change this to logarithm form. So I'll have log base 10, okay, well, we don't have to write the base 10 because this is a common log, of 20 equals x. Okay, so now how am I going to solve that for x? Well, x is equal to the logarithm of 20. All right, you may have noticed on your scientific calculator previously that there is an log button. Okay, so if you type in log base 10, or I'm sorry, log, which is understood to be base 10 of 20, okay, and it will give you that x is approximately 1.3. That is the power that you can raise x to get 20. Okay, I'm going to stop here and we'll move on and do some more of this in our next video.